Hello everyone. So in this session we are going to discuss about the lab 10. So in this we have to build the CNN model for the given TIF images. Here we have to handle the TIF images. Generally these are used for biological or in the medical field, and also some satellite images. All these are representing with the TIF format. So in that there is a scope of representation of various dimensions, and also we can represent more data in the image. So instead of RGB, the satellite images and medical images, MRI scans, all these are using the TIF formats. So how to use them? We are taking very simple TIF format. We are not taking the complex TIF formats. We are taking very simple format of the TIF images, and we have taken the data set. Here this is the original data set we are taking from the Kaggle only, and we have created the small data set in and uploaded in the Google Drive. So we can see that data set. Actually this data set is having the CT scan images. The actual aim of this data set is different, and we are taking in a different way. The images, the CT scan medical images data set is having the CT scan image, and also they are maintaining the patient age and also contrast. Contrast means there will be some liquid will be injected or taken by the patient to get more clarity on the CT scan images. So whether the contrast was given to the patient or not before the scan, for this scan, that will be there, and age is also maintaining. So I am taking as the problem statement here, we have to take the image, CT scan image, we have to identify whether the contrast was given or not. So that is the problem statement here. So if you see the images data set, the data is the TIF images are available in the folder, and then the another data set, that is another file is available. This file is having the data about the age, contrast was given or not, and TIF file name. Of course in the original data set there is another format also given, so we are not considering that. We want to take only TIF image name and date, age, and the contrast. Contrast is true false it was given. So I want to take this. Here it is a very simple data set, with 100 samples only. So in this I just want to go through it. We have to take the contrast from this column actually, okay, and then we have to take the images from this column, TIF name images. Overview.csv is there. So for that we have to mount the drive, the first step. So we have to close the previous session and mount the drive. So connect to the drive to my account. And the dataset already added to my drive. So we have to import the required libraries. Here the required libraries, NumPy, Pandas as usual, OS to get the file and directory names, and PIL to handle the images, and Matplotlib to display the images. And here we have the TIF images. So how to read the TIF images? That is in the SK image library, skimage.io module. We have the SK IO module. In that we can read the TIF images. So we are reading skio.im read. We are reading the TIF image, and we are trying to display with plt.im show. We have to load this image, and then we have to execute the top one. The libraries, we have to execute the libraries and then execute this, so that we are getting the image here. And then now I want to resize it. To resize the image, we have the another module in the SK image, transform. In the transform, we have the resize image, resize of the resize method available. For that, we have to pass the image object, TIF image object, and size we have to provide. If you want to resize to 50 by 50, you have to use this. And then it is a 50 by 50 image. Say this. This is the 512 by 512. See the clarity. And this is the 50 by 50 image. You can find the pixels also. And then we have to load the images. Actually, we are building the method. Here we have to provide the path, and we have to give the images, image files, image size, how much size you want to resize it. We have to provide that. These are the two arguments given in the load images method. And what we are passing is, let us see what we are passing. First of all, I want to load the overview.csv by using the read CSV, pd.read.csv. I'm taking that. And TIF image name, I want to see the TIF image name. So I'm just displaying, reading the file, that is overview.csv, and in that TIF name is like this. See here, only the TIF file name is available. We have to append the remaining path to this to open the image. So please remember this. And what I am calling, how I am calling is load images of data.tif name. So I am passing this output to the file, to the method, and I want to convert this into 64 by 64. Okay. Now, what is the method I am defining is, already the path means actually it is not the path actually. It is the list of file names, and we have to append the remaining path to the file name. Now path is available. Data, I am taking the data as the empty list, and for I in path, meaning that for every file name, and I am going with the skio.im read, and I am giving the entire path of the directory, TIF images directory. It is available in my drive. In my drive, I have placed this in separate folder. You may have directly in the my drive, because you are adding the shortcut to the my drive. Lab. Inside the lab, I have the data sets. The data sets, we are having the flower images, DLT10. Yes. In the DLT10, we have the TIF images. Here we have to take that path, copy path, and then you can paste it here. So that is what I have given, and then plus I, meaning that it is the individual file name. So it will read the image, and by using the transform, I am resizing it, and then reshape. I want to reshape it. Actually, this will be resized to 64 by 64 only, but our expected size is 64 by 64 by 1, meaning that only one layer it is available. We have, because of that reason, I am reshaping it, and then I am converting that SK image file, SK image format into the array, np.array of im, and then I am appending that to data, that is we have taken as the empty list, and I am converting, finally I am converting the entire data into the array and returning it. So all the images will be read, finally the list will be converted into array and returned. So I am just executing this also. and I'm calling the load images. So it is loading the images. Yes, it is loaded. Now what is Y here? We have not taken Y. In the previous examples we are taking the label also. We are getting the label also from there. So loaded images are in X, and we have to prepare the Y separately because it is in the CSV file. So if you execute this again, we are getting this. I want to take the contrast in the file name. The contrast, I want to take the contrast as the Y, and I want to create the Y code also, so that I'm converting that into this. And actually the contrast as is having the Boolean value. The Boolean value can be converted into the integer by using the as type of int. Directly you can convert that into int. True false only, 0 1 will be taken. So I'm converting that, so that I want to check the shape of X and shape of Y. It is 100 images, 64 by 64 by 1, and 100 labels are there. The labels are also 0 1 only. There are two categories, whether the contrast was given or not. And then I'm dividing that into train test split. This is also common in all our programs. And I'm defining the model with a convolutional neural network. See here, in the first layer, 16 units, 3 by 3 kernel, and 64 units in the second convolutional layer. I am using the 64, and I am adding the max pooling also in between. After convolution, adding the max pooling. This we discussed in the theory. So max pooling, it will reduce the size of the image by 50% if you give the 2 by 2 kernel size of the max pooling. So after giving the two sets of convolutional layers, and then we are flattening the feature map. After flattening the feature map, we are adding that to dense directly with 2 units, because we have the two categories. Directly we are giving that with the softmax as usual. Of course you can use the sigmoid also for this case, but I am going with the softmax. Sparse categorical cross entropy, and optimizer is Adam as we are taking, and fit the model also. I'm fitting the model, meaning that training the model. So this I'm getting 87, 72. Now I'm getting 100% for 25 epochs, 100% for 25 epochs my model, and test data set. For the test data set, I'm getting 0.8, meaning that 80% accuracy. So this is okay, acceptable. We can accept, but if you want, you can handle the overfit also, overfit methods also. But so we have to go with that. I think we have to go for the overfit, because the problem statement is here. The problem statement, CNN take the TIF images. We have fitted the model, and also check whether your model is overfit, underfit, or perfect fit, and we have to handle the overfitting by using the regularizers and the dropouts. So we can add the dropout layer, and we can add the regularizer also. There are two regularizers available, L1 and L2. In this, let us try with the L2 here. L2 or L1, you can try anything, and also the dropout layer. See, this is the model without any overfit handling, and now we have to go for the overfitting. We are observing that we have the overfit situation, because 100% and 80%, there is a 20% difference is there. So we are adding the overfit handling technique. That is, we are adding the dropout layer with 20%. This we discussed in the theory. This will drop the number of neurons randomly. 20% of the units will be removed in the convolutional, So out of these 16, 20% will be removed, and then we are adding the batch normalization also. This is another technique for handling the overfit and make the training easy. Of course, it is optional. If you want, you can use, or this is optional. You can go for that. And another thing is we are adding the kernel regularizer. This is the hyperparameter we are using for every layer. We can add the kernel regularizer. That is L2 I am taking. For each convolutional layer, we can add the kernel regularizer. And activation is relu as usual. I'm just adding the dropout layer and add the kernel. First you start with the adding the dropout layer and then add the kernel regularizer. You can try with that. And the remaining is same. Loss is sparse categorical cross entropy, Adam optimizer, and matrix is accuracy, and fit the model. So let us go with this. Training the model. Training the model is this. Regularizer means we are adding some noise to the weights so that the overfit may be handled. There is no guarantee that it will be handled. See, still it is 8 only, meaning that 100% and 8%. So the training is also more because already it reached one around 12 epochs. So we can change the training also. Training, we can reduce the training. I think we can go with instead of 35, I can give just 15 epochs. And I can train it again. You can train with different combinations also, so that you will get this. So already if you are 15, we are getting 100%. Let us see whether it is still 8 only. So we can use the regularizers and dropout layers. We can use the dropout layer. We can use the L2 regularizer. It is not getting. So you can try with L1 also. I'm trying with L1 regularizer at this moment instead of L2. We can go with different combinations. So in 15 we are getting 97. It is more down. So we have to go with the L2 regularizer, and you can add one more dropout layer, or you can increase the dropout layer with 0.3. We can go with the 0.3 dropout. You can try with this also. You can try with different combinations. You will get the perfect fit. You should get for the perfect fit. You should try for the perfect fit. You can go with this. So it reached 8. Now you can go with the instead of L1. Now again I am replacing with L2. You can try with this L2 regularizer. L2 regularizer, it is a squared noise can be added. So I think it may get success here. I think 75. So again you have to tune it. Of course, the regularizer parameter can be also given. Now I am going with the new image and same prediction for the new image. What is that new image? We have to go with this. This is like this. We can predict the label for the new image. So this is what we have to perform. In this exercise, we have concentrated on the handling the overfit by adding the dropout and the kernel regularizers. Of course, we can tune it more. You can practice that. Thank you.